Hi, this is Terry. Glad you're here today. Hope we can do something that will be helpful and useful for you. Today we're going to talk about basics of solving equations. And we're not going to get into it in a lot of detail, but we want to get the idea and concept down later and then now, and then we'll talk about later how we apply these ideas to what math is really all about, and that's finding solutions to problems that we need to talk about. First of all, we need just a bit of a review. We need to remember what the word expression means. Now, my son always used the word sweet. And I know that when I say that word sweet, that some of you know what he was talking about. But the thing about an expression is it really doesn't say anything, because it didn't say anything about sweet, and different people can interpret it differently. And that's true. That's what expressions are. So when I talk about a math expression, then I'm talking first of all about an expression. So it's not going to say anything, but it's going to be about math. So when I think of something in math that doesn't really say anything, I can say something like this. Does that really say anything? 3 plus 2. Doesn't tell you to do anything, it doesn't ask anything, it just says 3 plus 2. So what? But what makes it a math expression? Well, I've got a 3, a plus sign, and a 2. Those are all mathematical symbols, so this would be an example of a math expression. Now, algebra is the study of the use of variables to represent numbers we don't know while we find out what they are. So basically, algebra involves using variables to represent numbers. So if I wanted to know about an algebraic expression, it would be something like this. X plus 2. Does that really say anything? No. So it qualifies as an expression because it doesn't really say anything, but it's algebraic because it has a variable in it. So anytime we're talking about using variables, we're talking about algebra and algebraic expressions. Now we just go through this because what we're going to talk about next is what's the important part of this. We want to talk about situations where what we're dealing with actually does say something. In English or in grammar, whatever you're talking about here, when you have something that has a complete thought, what do they call it? Sentence? Everybody familiar with that? A sentence has a complete thought. Well, it's possible in math to have sentences that have complete thoughts. And in math, we give those sentences, those mathematical sentences, a special name. It's called an equation. Now, if I had something like this one, it would have a complete thought if I did what? I mean, think for a second, what would complete that thought? Anybody see what it is? In other words, if I added an equal sign and I put a 5 there, then it's actually making a full and complete thought. 3 plus 2 equals 5. And that's true. We know that. Hopefully we know that. But that is a complete thought. And so this is called an equation. I can do the same thing here. If I put an equal sign and say I have a minus 3. Now, think about what that says. Some number add 2 is supposed to be equal to negative 3. That's what it says. Now, I may not know what the number is, but the sentence says some number plus 2 is supposed to be equal to negative 3. That is a complete thought. So any time at all that we have a mathematical expression and we add something, so we've got an equal sign and something that completes the thought, what we have is called an equation. So this is an example of an equation. let's take an example, and we'll make it a nice simple one. Let's say I have x plus 3 equals 5. Now that says there is some number. If I add 3 to it, I get 5. So there is a complete thought there. Now, if you're, let's say, normal, and you're working with something, you got something like this you're working with, what is it that you want to know? If I say some number plus 3 is equal to 5, what does the normal curious person want to know? Okay? We want to know what that number is. In other words, the number which, when I add 3 to it, gives me a result of 5. Okay? That's what I want to know. I want to know something like this. X equals, and then I want to know what that number is. And that's all I'm talking about. Now let's just look at a word. Let's suppose you're dealing with some kind of problem situation in your life. How do you tell when you've found the solution? Okay, and it doesn't matter what it is. You decide you want to go on trying to decide whether you want to go on a date with a certain person. How do you know if your decision, you decide to do it, how do you know if that was the solution? If it worked. Now, words mean what they mean. And solution is what works. And I don't care what we're talking about here, math, whatever it is, the solution is what works. So when I look at this, I want to know what that number is that will actually work. Now, you probably can look at that and tell what that number is in this case, because it's saying some number added to 3 is equal to 5, and with nice small numbers like that, we can usually figure that out. And we can probably tell that the x would have to be 2. Now, if you want to see if, in fact, that is the solution, then remember what we said. Some number plus 3 is supposed to be equal to 5. When I say this, x is equal to 2, I'm saying that number is equal to 2. So when I look up here and see, I got to find out if, in fact, that is. So is it true that 2 plus 3 equals 5? Okay, it is. We know that. And so then we would say that 2 is the solution to this equation. 2 is the solution to this equation. Okay, now what I want you to do then is I want you to tell me if, let's see, I want to know if a 2 is a solution to this equation. Because the equation is a little more complicated, so it's not quite so easy to look at. So here's my equation, 4x minus 3 equals 5. I want to know if 2 is a solution to that equation. Now think about what we said. The solution means it would work. This is, we're asking now, is x equal to a solution? In other words, is that the number 2 what this number here that I was looking for? So I put 2 in place of the x, because that's what this says. So is 4 times 2 minus 3 equal 5? Well, 4 times 2 is 8. Subtract 3 is in fact 5. So 2 works in this equation, so we say that 2 is a solution to that equation. Okay, everybody got that? That's the idea that we're talking about here. Now, what we want to know, we want to be able to talk about some ideas that will actually allow us to find solutions if we just have an equation. I know that some of these are pretty simple and some of you can look at it and tell what they are, but they get more complicated, and we want to know what we can do to find a solution even when they are more complicated. And I'm going to talk about a couple of things that we can use. I'm going to use kind of layman's terms rather than mathematical terms because I want it to be something just about anybody can understand. One of the things that I like to talk about is the principle of balance. And to be able to give you something that you can use to visualize this, picture being on a teeter-totter with a friend. And picture yourself being totally in balance. In other words, the teeter-totter is straight out with each of you on the end wherever you are. And you're in balance. If that doesn't work for you, you never were able to play on teeter-totters, think of a chemistry lab when you're trying to measure, find the weight of some kind of substance. So you have a scale, and the scale has the arms that come out, and there are little plates down there. And you put the material you're weighing on one of those plates, and then over here on the other plate, you add weights until finally they are in balance. Okay? So visualize that or anything else you can think of balance, because we're going to be talking about the principle of balance. Now, if I, let's say teeter-totter, if you can try and get into this. You got two people balanced on a teeter-totter. If I come up and hand a 20-pound weight to one of those people, and that's all I do, what's going to happen? Okay, you're going to go down. I don't know how far, but you're going to go down some. You're no longer in balance. To keep it in balance, what would I have to do? Okay, got to do exactly the same thing to the other side. So if one person, you got two people in balance and they each got a bunch of weights. So I come and take away weights from one of them, then what's going to happen? Okay, they're going to rise, the other one's going to go down. To keep it in balance, what would I have to do? Come over here and take exactly the same weight away from the other side. If I double the weight of one person, to keep it in balance, what am I going to have to do? Go over here and double this weight. Double is kind of like multiplying by 2. So if I multiply one, I got to multiply the other by exactly the same amount. If I came and took half of the weights away from one, I'd have to take half of the weights from the other one. Basically, the idea is you have to do exactly the same thing to both sides if you want to maintain the balance. So when you see this written up here, or you see it anywhere else, the principle of balance, that just simply means whatever you do to one side, you got to do exactly the same thing to the other side. Now, some other things that we need to know. Pick a number, any number. I want you to add 5 to your number. Okay, you got it? Now to get back to where you started it, what do you have to do? Okay, you got to undo that. You got to undo that, so you take it away or subtract. If I subtracted, but I want to keep the balance, what am I going to have to do? I'm going to have to subtract from the other side. So we have here that addition and subtraction undo each other. Now, if I multiply one number by 2 to get back to where I started, what do I have to do? Divide. If I divide, what do I have to do? Multiply. So, in the same way that this worked out, multiplication and division undo each other. Okay, the mathematical form of things, what we talked about before in the principle of balance, looks like this. If A is equal to B and C is a real number, then A plus C equals B plus C. Or, same thing would be true if I have minus. If A is equal to B and C is some real number, then A plus or minus C equals B plus or minus C. In other words, as long as I add the same thing to each side is still equal, or if I subtract the same thing. By the same token, if I multiply each side by the same thing, it maintains the balance. And we talked about the third one, if we divide. Now that's what it looks like in a math book, and that's well and good, but if you're thinking about the idea of balance, so you've got that idea clear in your mind, then it's a little easier to know what to do with. So what we're going to do is we're going to use this kind of information to be able to solve, which means we're going to find solutions for equations. And it's really a basic, simple thing to do. If I have, excuse me for a second, and by the way, when problems are really simple, don't get into a habit of guessing, because it's easy to make them hard enough that you're not going to be able to guess. Let's say I have this. Some number, subtract 19, is supposed to be equal to negative 31. Now I don't know if you noticed that, but just by putting negatives in there, I already made it harder to just find out what the number is. But let's go through this so you can see what kind of happens here. If I'm asked to solve this, that's the direction I have, then I want to know what x is equal to. That's what I want to know. So basically what I have to do here is I have to get x by itself, or isolate it, on one side of the equal sign. And I look up here and I say, okay, if I'm going to balance, if I'm going to get this down here where it needs to be, I've got to get rid of that 19. Well, I look at what's been done. They have subtracted 19. I want to undo that. So then I ask myself, well, if they subtracted, what undoes the subtraction? And that's pretty simple. I'm going to add 19, because addition undoes subtraction. But the principle of balance tells me if I add the 19 here, then I'm going to have to add the 19 over here. Notice, minus 19, add 19, they're going to cancel each other out, basically, because it's gone. Okay, that leaves the x by itself, what I want it to be. So I just have to come over there on the other side and say, okay, well, what's it equal to then? Because this tells me what it's equal to. So I got minus 31 plus 19. And here's where I start using my visualizing. I'm here on the number line at minus 31. Can you see that? Minus 31. And I'm adding, so that's taking me in the positive direction. But I'm only adding 19, so it's not going to be enough to get me into the positive. So I know my answer is going to be negative. And when I go from 31 to 19, I want to know where I am. Well, if I subtract, if I find the difference between 31 and 19, I know what's left, how far I am left in the negative, and that gives me 12. Now, if I want to check my answer to make sure it's true, then I just simply put that negative 12 in there and see if negative 12, picture where you are, you're going to subtract 19, see if you get negative 31, and we do, and so that's it. Now the next one. This is our problem. Solve this equation. Well, first of all, I know that if I'm going to solve, what I want to do is I want to find out what x is equal to. So I'm going to get x by itself, isolated on one side of the equation. Then I look up here. This says they've added 7 to my number. I don't want that there. I want the number, just the number. So I'm going to undo that, remembering now that addition and subtraction undo each other. I'm going to subtract 7. But because of the principle of balance, I know if I subtract 7 there, I have to subtract 7 over there. Plus 7, subtract 7, they undo each other, cancel each other out. I know that. So now I just look over here and see what I have to do to get the answer. And I've got minus 4, picture where you are, you're subtracting, think of the direction you're going, 7 more in that direction, I get x minus 11. And sure enough, minus 11 plus 7 is equal to negative 4. Okay, let's just quickly do one of each of the other for today, and then just practice with the basics, and when they get more complicated, we'll go back into it in more detail. Let's say we have 5y equals 12, and we're supposed to solve that. Now, in this case, you got to know this, so you got to make sure you're clear when you look at this. When you see 5y written like that, that means 5 times y. I want y by itself, that means I've got to get rid of the 5. If they've multiplied by 5, what's going to undo that? Division. So I have to divide by 5. Now, if I divide one side, because of the principle of balance, I've got to divide the other side. Now, 5 divided by 5, or for that matter, any number divided by itself is 1. 1 times y is just going to be y. So we're just basically going to say those numbers cancel each other out. So I get y by itself. And my answer is 12/5. And you can write it in this form now. If you want to write it in the mixed number form, remember, we're dealing with fifths, so it takes 5 of them. We got too many. If we divide 5 into 12, we find there are 2 full groups of 5. So we get a 2, and there are 2 left over, and they are fifths. And so there's my answer, 2 2/5, or 12/5. Either one's fine. And let's look at one other one. So we see the other kind. Let's say we have m divided by -3 equals -4. Okay, in this case, they have divided by -3. I've got to get rid of the -3 because I want m by itself, so I want to know what m is equal to. So, they've divided, then I ask myself, okay, what undoes division? That was multiplication, but I got to multiply by whatever is there. So, I'm going to multiply by -3. You may want to make it look like a fraction so you know what to do. But if I multiply by -3 on the left side, then I have to, because of the principle of balance, I have to multiply by -3 on the right side. Notice what I did there. I put parentheses around me to kind of keep this clear. If you wrote this, -4 - 3, excuse me, you probably would not know exactly what to do. So I make it clear that I'm going to be multiplying. Now, I've got a -3 in the numerator, 1 in the denominator. Anytime there's the same number in the numerator and denominator, they cancel each other out. That leaves me the m by itself. And to get my answer here, I go -4 times -3. When I do that, I remember the rules. How many signs are there, or negatives are there? So when I multiply and I've got 2 negatives, what's the sign going to be? Positive, because it's even, and my answer is +12. So if you just will follow these rules, think about what you're doing, one thing at a time. It's fairly simple to do this. Whenever you're doing anything in math, make sure you get the sign, then the number, then the variable, and then you'll be okay. So if there's any questions at all, then we'll be going back into this in more detail when it's a little more complicated, but this is just kind of an introduction so you can kind of get a feel for what's coming. Okay? Thanks. Hope you had a good time today, and we'll see you again next time. Bye.